Okay, so remember last time I talked about we were coming up to multiplying polynomials? Here we are, multiplying to polynomials. So before we get into multiplying polynomials, there's a few things we want to make sure we recall from our properties of exponents before. So remember, if we are multiplying two things and the base, so in this case the base is what we call x, if the base is the same, the base doesn't change, but we add the exponents. So this is going to become x to the 11th. Here, this is still what we would call the base, so the x, but we multiply the coefficients and add the exponents. So this will become 12x to the 11th. And then more generically then, just to really make sure, hopefully, we understand what is happening, here g and h are just some constants, m and n are two other constants, and x is our base. So this becomes g times h x to the m plus n. Okay? So these are our properties of exponents. We want to make sure we recall. And again, if we are multiplying the bases, we still multiply the coefficients in front of the bases. Recall our vocab, terms, groupings who have numbers and variables separated by addition or subtraction. When multiplying polynomials, every term in the first polynomial must be multiplied by every term in the second polynomial. Similar to addition, it doesn't technically matter which polynomial you call the first or the second, because with multiplication, 3 times 4 is the same as 4 times 3. So the order in which we do it does not matter. We just need to be meticulous in making sure that every term in the first polynomial gets multiplied by every term in the second polynomial. Sounds good. Let's get to it. So if we want to multiply negative x squared plus 2x plus 4 times x minus 3, what I would highly recommend doing is first write these in parentheses so we can see what this looks like, and then it will help us to actually do the multiplication, hopefully. So each term, so I'm going to do negative x squared times x, that will become negative x to the third. Negative x squared times negative 3 is plus 3x squared. Now I'm going to do 2x by each term in the second polynomial. So 2x times x is plus, spent all this time color coding to make this fun and nice. So 2x times x is plus 2x squared. And again, remember there's an exponent here of 1 and an exponent here of 1, so that's how I'm getting the squared. 2 times the 1 here gives me the 2. And then 2x times negative 3 is going to be minus 6x. And then the last one, 4, gets multiplied by h. So this will become plus 4x, because 4 times x is 4x, and then minus 12. So that's the first step. That's theoretically the hard part. Now, it becomes an addition problem. So we identify our like terms. Got like terms here and like terms here. So I'm going to go ahead and combine like terms. Then I end up with negative x to the third plus 5x squared minus 2x minus 12. Nice. That was fun. Okay. I want you to try the next one. Pause the video, multiply these two together. Unpause when you're ready to discuss. Alright, so hopefully you got 3y to the third plus 13y squared minus 8y plus 10. If you didn't, let's look at how we did this. And even if you did, let's still look at how we did this. So again, first thing I did was what I wrote here in the black, and that is I just showed the multiplication by putting each of these in parentheses so that it's easier for me to keep track of the actual distributing. And that's what this process is called when I'm multiplying, in this case first, the y by each term in the second polynomial, that is distributing. So we call that distributing, and that's what we see here in red. So y times 3y squared is 3y cubed, y times negative 2y is minus 2y squared, and y times 2 is 2y. And then I distribute the 5. So 5 times 3y squared is 15y squared, 5 times negative 2y is negative 10y, and 5 times 2 is 10. Then it just becomes a matter of combining like terms, and I get my answer. Nice. Okay, next one. So here, this is going to be a little bit more work. We have three different, what we call binomials, because they're each two terms. So when we have this, again, I'm going to write this out with parentheses first, just to show the multiplication to keep track of my distributing. So here, I have to make a choice. It doesn't matter what I choose. I mean, in life it does, but sometimes. Anyway, I have to make a choice here. I want to multiply two of these binomials together first, and then just ignore the third one. It doesn't matter which two I choose, I just have to make that choice. So I'm going to multiply these two together first. All right, and I'm just going to kind of ignore the x plus 5. So I'm going to do x times 4, and negative 1 times x, negative 1 times 4. And we'll end up with x times x is x squared, x times 4 is 4x, negative 1 times x is minus x, negative 1 times 4 is minus 4. I still have the x plus 5. Now, notice that we have a couple of like terms, so let's go ahead and combine those. And we get x squared plus 3x minus 4 times x plus 5. Now this becomes just like the first problem we did today. So we can go ahead and distribute the x squared. So x squared times x is x to the third. X squared times 5 is 5x squared. Distribute the 3x. 3x times x, 3x squared. 3x times 5, 15x. And distribute the negative 4. So it becomes minus 4x minus 20. And now we'll combine like terms. X to the third plus 5 plus 3 is 8x squared. 15 minus 4 is 11x minus 20. Hopefully I did that correctly, because I was going quick. But that's the process. And again, I could have ignored the x minus 1 and distributed the x plus 4 and the x plus 5 first. Then this step would have had different numbers. So the step here in purple, but my result in the end should still be the same. Questions on that? Okay. Okay, so here I want you to try each of these. Some of them are going to be a little more work than others. I do want to also point out here, 9y minus 2 squared is this. This is what the squared means. It means that we have two of those things. ab plus 4 to the third means we have three of these things. Okay, so this problem here is going to be very similar to what I did here, where we had three things. Pause the video, try to do those on your own. Unpause when you're ready to discuss. Okay, so I've got a lot of work going on here, so let's talk through it. First one, for A, we should hopefully get 16n squared minus 25. How do I do that? 4n times 4n is 16n squared. 4n times negative 5 is negative 20n. 5 times 4n is positive 20n, and 5 times negative 5 is negative 25. Now notice here these middle two like terms, they cancel each other out because this is negative 20 and this is positive 20. So that's why we end up with just 16n squared minus 25. I do want to point out, you don't have to know this right now, but it is a nice thing to start to recognize. Anytime we have two things, two binomials, binomial means that we have two terms that are exactly the same, but with an opposite middle sign. So this one's plus and this one's minus. It doesn't matter the order in which that is. The middle terms are always going to cancel. This result here is what we call the difference of squares. So you may have heard that term before. You may remember it. And what that's referring to is that this right here is a perfect square, right? 16 is a perfect square, n squared is a perfect square, and then 25 is a perfect square. And when we use the word difference, that means subtraction. The reason why this is nice to recognize is because I know this is always going to factor into two things that are exactly the same, but with opposite middle signs. For B, again, here I write it as 9y minus 2 times 9y minus 2, and I distribute. 9 times 9 is 81, and then y times y is y squared. 9y times negative 2 is negative 18y, negative 2 times 9y is negative 18y, negative 2 times negative 2 is positive 4. Combine the like terms here in the middle, and that becomes negative 36y. So we get 81y squared minus 36y plus 4. Sorry if this is going to this one here. This is what we call a perfect square trinomial. Again, you don't have to know this right now, but these are terms we're going to hear later on in this unit as well, so starting to recognize them now could be helpful. The reason why we care about that is similar to this, is if I recognize or know something is a perfect square trinomial, then I know it's always going to factor into two things that are exactly the same, as opposed to here, difference of squares factors into two things that are the same but with an opposite middle sign. Here, they are exactly the same. Okay, and then the third one, this one was more work, ab plus 4 all to the third power. So this is ab plus 4 times ab plus 4 times ab plus 4. So first I just multiplied the first two together, and ab times ab is a squared b squared. ab times 4 is 4ab, 4 times ab is 4ab, 4 times 4 is 16. Combine these like terms in the middle, and I get 8ab plus 16. The a squared plus b squared stays there also. Note that this right here is another perfect square trinomial. Just point it out. You don't need to memorize that yet. Now I distribute into the third binomial. A squared b squared times ab is a cubed b cubed. A squared b squared times 4 is 4a squared b squared. 8ab times ab is 8a squared b squared. 8ab times 4 is 32ab. 16 times ab is 16ab, and 16 times 4 is 64. Now we combine like terms, and we end up with a cubed b cubed plus 12 a squared b squared plus 48ab plus 64. Nice work. Thank you. Next one. Take a second. Explain why this is not the same as this. There are a lot of correct explanations. Pause the video, think about it, unpause when you're ready to discuss. Okay, so I'm trying to kind of show two different reasons here. First one is that we know from what we just did in the previous problem, and then one of the problems earlier before that, so here, and this problem here, that x plus 2 to the third power is this, right? And then without multiplying that out, I know, just from doing this previous one, the answer is probably not going to be as simple as x cubed plus 8. And by probably, I mean it's not. So those aren't the same. The other reason is properties of exponents. So exponents do not distribute when we have addition or subtraction. And what I'm talking about here is this. So I have x plus 2 raised to the third, so this does not distribute because of this addition. To give you a counter example, if we had 2x to the third, so now what's the operation? The operation between the 2 and the x is multiplication. And remember, 2x and x times 2 are the same thing. This does distribute. So exponents do distribute in multiplication or division. So this is the same as 2 to the third times x to the third. Same if I had x over 2 to the third. This would be the same as x to the third over 2 to the third. But with addition or subtraction, that does not happen. What did you say? Okay. Well, let's wrap it up. When multiplying polynomials, every term in the first polynomial must be multiplied by every term in the second polynomial. It's really just a matter of organization. Takes time. It's a little tedious sometimes, but it's totally worth it in the end.